Welcome to the Tuesday edition of Juan's World. As I was musing on Friday and thinking, well, I've got a lot of work to do and I don't know when I'll be back next. Well, it turns out that I've got a little bit more time. So maybe this week and next week I'll have enough time to post a video. And I did think about cooking, and I'm going to show you some shots here of things that I was thinking about. One of the things I did last week, for example, was to make this dish, which is duck breast in a sauce of lemon and hot peppers. So it's kind of a hot and sour duck, I guess, with some leeks and some mushrooms and whatnot over noodles. Well, I think you can pretty much figure this one out. You put some lemons and some hot peppers in a sauce that you're making, and you braise the duck, brown off the skin side, and then braise it with the lemon and the hot peppers, and add what you want, leeks, mushrooms, what have you. Not a problem. I've also been making anchovy toast, very old-fashioned tea time snack, made by making some toast, buttering it, and adding anchovy paste to the top. Very simple. I think it's not something that people make anymore, but I don't know. I found some anchovy paste in my Australian supermarket when I was out shopping the other day, getting, among other things, duck breast, and came across the anchovy paste and thought, anchovy toast. And then the last one here is treacle pudding, which is a steamed pudding. It could be made with treacle, or in this case it's made with golden syrup, and it's just a suet pudding with golden syrup. Also very old-fashioned English. All right, so there's my there's my meals and snacks for the day. And now we can get on with today's topic, which is Occam's razor. Now, Occam's razor, sometimes called the rule of parsimony, very old-fashioned, not old-fashioned, I'm still thinking about my cooking, an old idea that is still current within much of the natural and social sciences. Not all, but a lot. And it can be expressed in a number of different ways, but the basic idea is that if you have a problem that you want to solve, like why does the sun rise, why do the stars move across the sky, why do the planets move in different directions, and so on and so forth, your solution is going to make a number of assumptions, or what we sometimes call axioms, although that's also a complicated issue. I don't want to get into it, but you make certain assumptions, and the rule of parsimony, or Occam's razor, says the fewer assumptions that you need to make in order to get your hypothesis to work, the better. That's it. I mean, it's ascribed to William of Occam, an English monk and philosopher of the 14th century. But that's just a vague ascription with no justification. In fact, going as far back as Aristotle, we can find philosophers making the same basic statement, that it's not just that the fewer assumptions is better, is that the if you have competing hypotheses, the one that has the fewer assumptions is likely to be the correct one. Or at least it's better than the one that makes more assumptions. All right, so this is all very abstract. So let's put it in terms that we've talked about several times before. That is the Earth flat or an oblate spheroid? Well, when you put them side by side, one of them needs to make an enormous number of assumptions more than the other one does. So if you think of the Earth as an oblate spheroid rotating once on its axis 24 hours a day, in one day, and revolving around the sun in around 365 days, you can explain a tremendous amount of things, but you do have certain problems. And one of the reasons that people didn't like this idea for a long time was that it didn't meet certain criteria that people felt it should meet. And the number one was that if the Earth is moving, if it's rotating and moving around the sun, what's moving it? Because we know that here on Earth things don't move. Things stay still unless something pushes them. And secondly, what keeps the Earth moving around in a circle? That's all difficult to explain. And number three, why can't we feel it moving? Because when you get on a train or a bus or a car or whatever, you can feel the motion. So why can't you feel it moving? Well, there are the laws of physics have explanations for all of that. The Newton's law of first law of motion says that a body at rest will remain at rest. Okay, very good. And a body in motion will continue in motion unless acted upon by another force. So there's nothing. We don't need to explain what keeps the Earth moving. It keeps moving because nothing's stopping it from moving. And why does it go round and round in a circle, or it's actually an ellipse? Why does it go round and round in an ellipse? Because of gravity. It wants to keep going straight, but the gravity that is exerted on it by the sun keeps pulling it towards the sun, and so it keeps wanting to go, and the sun keeps pulling it around, and so the two forces balance each other, and it just keeps going round and round and round the sun. Okay, and why don't we feel it? Because we don't have any mechanism for feeling motion. If you're in a vehicle that is moving, but with no external points of reference, like no windows, for example, and there's no bumps or jerks or anything that is just steady, straight motion, you cannot tell whether you're moving or staying still. Because we don't have a receptor for motion. We have receptors for acceleration. Like if you are speeded up or slowed down, then you can feel it. But steady motion, can't feel. I remember very, very clearly, and it was a great, early years experiment. When I lived in England, I used to periodically go up to London and take the train back to where I lived from Paddington Station. Paddington Station is a very big station, and there's lots of parallel platforms. And I would get on a train that would leave at some point, but I usually had to sit and wait for 10-15 minutes or so in the carriage as it filled up and it wasn't ready. It wasn't time for it to leave yet. And there would be trains on platforms on either side, and I could see them. Quite often, the train, let's say to my right, would pull out of the station. Now, if I just focused my attention on that train moving, I couldn't tell whether it was going that way or I was going this way, because it just felt the same. It felt like all I had to do was just switch my mentation, I guess you would think of it as, and I could imagine myself going in the opposite direction, because in other words, I wasn't able to tell whether this train was going this way or this train was going this way. Like which was it? I couldn't tell until eventually the train left the station, and and I realized I'm still sitting in a stationary train. And that's one of the things that Einstein talked about the relativity of motion. That unless you have some kind of cosmic orientation, coordinate system, you can't, in any absolute sense, say whether you are moving or not. And if there is no universal coordinate system, then talking about something moving in an absolute sense is rubbish. You can only talk about something moving relative to something else. All right, so all of that aside, if we have a hypothesis that the Earth is going around the sun and it's spinning on an axis, we can explain the seasons, lunar eclipses, solar eclipses, day and night, the seasons. It explains just about everything that we're interested in. Why the stars move, why we think the sun moves, or the moon does move relative to the Earth. But why do we always see the same face? Now, what if you think that the Earth is like a pizza with ice at the edges to prevent the water from flowing over, and on top of it is a big dome that keeps the atmosphere in place? Well, you've got a ton of things to explain. How do you explain the seasons? How do you explain night and day? How does the sun above a flat disk illuminate half of it and not the other half? How does it do that? Do we have any kind of light source that we know of, that we've invented, that can, let's say, in this room, can light half the room so that it's all bright, and the other half is in complete darkness? Okay, but how do you explain the seasons? How do you explain the changes in the lengths of a day from season to season? What causes things to fall? What would cause the water to fall off the Earth if the ice wall wasn't holding it? What's causing it to fall? And if it did fall, what would it fall into? What's above the dome? And so on. I mean, you've just got numerous things to explain that your particular hypothesis doesn't go anywhere near. And we call those explanations ad hoc explanations, because, like, I ask you a question and you give a different kind of answer. Why is there night and day? Why are there seasons, and so on? And you have to give a different answer. Well, the sun speeds up and slows down. It moves from one tropic to another. Now, how does it do that? Don't know. Yeah? Whereas the heliocentric model explains it all. The tilt of the axis of the sun explains the seasons, and explains the changes in the lengths of days and nights, and so on and so forth. Like it explains everything in one little package, whereas flat Earth needs 10, 15, 20 different explanations to explain it all. Well, Occam's razor says, okay, I've got to choose between, there's multiple ad hoc explanations over here for flat Earth, and this one simple explanation. I mean, it's not all that simple, but it's simple enough over here. Which am I going to choose? I'm going to choose the oblate spheroid rotating on its axis and revolving around the sun. End of story. That's Occam's razor. My question: can we prove that Occam's razor is an airtight theory, or an airtight explanation of how we go about exploring and analyzing phenomena in the natural and social sciences? No. We have to take it on faith. We have to just accept that simplest explanation is better. Case closed. Now this feeds into what I've talked about in the past, is that this becomes your worldview. But the thing is that simpler is better doesn't always work. And it certainly doesn't work when it comes to something like film or literary criticism. Like if I go to a movie or I read a book, and I come back and you say, how was it? And I say, bad. Or good. All right, simple. Occam's razor at work. Not helpful. I need a much deeper, longer, more complicated explanation to be satisfying. Why was the movie good? Well, let's start off with the actors, and then we'll talk about the script, and we'll talk about how it's put together, and the lighting, and production values, and blah 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 blah. And we can go into great lengths in terms of our critique of the movie. That's the reverse of Occam's razor. That's saying that the more complex answer is the better answer. So now, the $1 million prize. So Occam's razor works sometimes, doesn't work sometimes. Does it work in anthropology? And that's the question that I'm not really going to answer. But my mentor Rodney Needham did try to answer it once in a paper that I attended many years ago, and I had a long discussion with him about it, because the answer, as has always been true in anthropology, going all the way back to Alfred Kroeber, who was Franz Boas's student. Alfred Kroeber asked, basically, do we accept Occam's razor or reject? I mean, he used different terms, but I'm going to put the words in his mouth. Do we accept Occam's razor or reject it? And his answer is, yeah. In other words, we can do both. It just depends on what we're dealing with. So there's Occam's razor. I hope you have a solid week. And please like, please subscribe. I'll be back on Friday, and I'm going to be asking a different question, but it's related to this one. I'm going to be asking the question, who are they? Now, because conspiracy theorists for decades now have been saying, they do this, they do that, they say this, they want this. Who are they? That's Friday's question.